Today we're going to cover 4-2, which is angle relationships in triangles. Remember to take notes and complete your check it out questions. And any questions you have, bring into class next time. So we've got two learning targets. The first is I can find the measures of interior and exterior angles of triangles, and I can apply theorems about interior and exterior angles of triangles.
Okay, there are a lot of vocabulary words we're looking at today, so take out, in your notes, write down the definitions for all of these terms. Auxiliary line, corollary, interior, exterior, both the angles, and then the remote interior angles. And look at the example down here. It helps define, or gives you an example of the different interior and exterior angles.
All right, so our first theorem, triangle sum theorem, it's one that you probably already know intuitively. The sum of the angle measures in a triangle is 180 degrees. So measure of angle A plus B plus C is equal to 180. So here's A, here's B, here's C, and the measures of these angles are going to be, or the angles are actually those angles. One other thing on this slide is just definition and auxiliary line. So you can see we have our triangle here, and they've drawn in this auxiliary line here, this dashed line, and it helps it sometimes improves. Sometimes you need to draw an extra line to help you to find certain angles, and so that's what auxiliary line is.
So our first example, a little forensic stuff here. After an accident, the positions of cars are measured by law enforcement to investigate the collision. I want to use a diagram over here from the information collected to find, first one, the measure of angle XYZ. So we're looking for this angle here, the measure of this angle. And our triangle sum tells us that the degrees within a triangle, all three angles must add up to 180 degrees. So we can write an equation and solve for the measure of angle XYZ. Okay, so in solving this, let's just set x, or the measure of this angle, equal to x, and that's going to eliminate some of our, all the variables and other letters there. So we know the one angle is 62, plus measure of the other angle, plus the measure of the angle we're trying to find, must be 180 degrees. Solving for x, we get the measure of angle XYZ equals 78 degrees. Our next example, we want to find the measure of angle YWZ. YWZ, so we're trying to find this angle in here. Okay, in order to find an angle down here, we needed to use the triangle sum theorem, because if we need to find the measure of the angle in here, so 180 minus 62, these is 118. So then we have this angle plus this angle plus this angle must be 180 degrees. Solving for x, we get x to be 50, or the measure of angle WYZ equals 50 degrees.
All right, this is your check it out problem. So they want you to find MJK, and just so you know, you can see, which you might not be able to see, J is right here, M is right here, K is right here. So it might be a little bit hard to see. So go ahead and find angle MJK.
And notice the angles are congruent there. You might need that information also.
Right, so this angle is congruent to this angle. Okay.
Okay, so now we're looking at corollaries. The two corollaries we're going to talk about or show you today all come from the triangle sum theorem. And the first one, the acute angles of a right triangle are complementary, which would make sense. If we have 90 degrees here, that means these two angles have to add up to 90 degrees. That would make sense. And the second corollary, the measure of each angle of equal angular triangle is 60 degrees. Since the total is 180 degrees, three angles must be equal, then they have to be 60 degrees. So again, these would be intuitive, but these are corollaries you would be able to use.
All right, so the example, one of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? So we're going to set up a picture here and figure this problem out. All right, so I've drawn a right triangle, and I've labeled the angles A, B, C. C is our right angle. B is the one angle that's 2x, and we want to find out what A is. So I set this up. We know that the two acute angles in a right triangle equal 90. So the measure of angle A plus B is 90 degrees. I've substituted 2x in for angle B because that's what it is. And now I just subtract 2x from both sides, and I find out that the measure of angle A is just going to be 90 minus 2x. And that's as far as we can go on this one.
And now it's your turn. You have 3 check-it-outs for this example. Bring any questions you have to class, and let us know how you're doing with them.
All right, so a little bit of vocabulary. We looked at it a little bit on the first slide. Each exterior angle has 2 remote interior angles. So first let's talk about exterior and interior. So just like in our angles in parallel lines, if it's inside, it's going to be interior. So angle 1, 2, 3 are interior angles. Angles that are outside the triangle, like angle 4 here, is exterior. So this is an exterior angle. So it's telling us that this exterior angle has 2 remote interior angles. Remote means they're not adjacent, they're not next to each other. So for angle 4, they're remote interior, so they're inside the triangle, and they don't touch, they're not adjacent to angle 4. They're going to be angle 1 and 2 are the 2 remote interior angles to that triangle, to that angle 4.
Here are 2 theorems. The first one, the exterior angle theorem. It states that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So in this example, it looks like what we looked at on the previous slide, saying that measure of angle 4 is going to equal the measure of angle 1 plus the measure of angle 2. Because angle 1 and 2 are the remote interior angles. The third angle theorem states if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third pair of angles are congruent. So in this picture, we're given these 2 different triangles. We're told that angle L is congruent to angle R, and angle M is congruent to angle S. So therefore, we have to have these angle N and angle T have to be congruent, and that's what our conclusion is.
Right, here's an example. So we have a triangle with 2 interior angles, 15, or A and B, and we have 1 exterior angle, and it asks us to find angle B, which is this angle right here. So we'll set up an equation using the exterior angles theorem and solve that problem. Okay, so I use my remote angles theorem. Angle A plus angle B is equal to our remote angle, which is angle C there. So I substituted the expressions in, I combine my like terms here and solve for x, and I get x is equal to 26. And then remember, I want to find the angle, so I'm plugging it back in. B is 2x plus 3, which is 2 times 26 plus 3, or 55 degrees.
Excellent. Now it's your turn. You want to find the measure of angle ACD. In this case, it's looking for this angle ACD. You're looking to find the measure of that angle here. Good luck.
All right, here's another example. We're gonna use the third angles theorem because what do we know? We see that angle G is congruent to angle H in this triangle. So first of all, let's step back a little bit. We've got 2 triangles here that are overlapping, so it's a little confusing. There's one, and here's our other one. So angle G in the purple triangle is congruent to angle H in the blue one. Angle F in the blue triangle is congruent to angle I in the purple one. So by third angles theorem,
Out of ink.
I must be out of ink here. I better get a new color. So our third angles theorem says that these 2 are also congruent, angle K and angle J. So we'll set up that equation and solve to find K and J.
Like we just did from rows.
All right, so I've set my equation up. 4y squared is equal to 6y squared minus 40. I add 40 to both sides, subtract 4y squared, end up with 40 equals 2y squared, divide by 2, and I get 20 is equal to y squared. notice that these expressions have y squared in them, so we don't have to square root to solve for y squared. We can just keep y squared as 20, and then we plug that in for y squared in our expression, and measure of angle K is 4 times 20, which is 80 degrees, which is also the measure of angle J.
Nice. Now it's your turn. Find the measure of angle P, which happens to be up here, and the measure of angle T. And again, the third angle theorem, that tells us those two angles must be congruent.
All right, so to summarize, we had 3 theorems and 2 corollaries. Triangle sum theorem that tells us the angles in a triangle add up to be 180 degrees, and then 2 corollaries about right triangles that are derived from triangle sum. Exterior angle theorem, the measures of the 2 remote interior angles are equal to the exterior angle. And third angles theorem, if you know 2 angles and 2 triangles are congruent, then the third angle is also congruent. Auxiliary lines might be needed to help in proofs. And then just generally interior angles are inside triangle, exterior angles outside. And here's a remote, this is exterior, these are the 2 remote interior angles. So write down your questions, and we will go over everything and go over the check-it-outs next time.